Alright, today we're covering 6.2, which is more trig equations. So you'll notice this one says starter. We're actually going to be doing this one as a starter in class. So I want you guys to take a peek at this problem right here. 4 cosine squared theta minus 1 equals 0. And the key to this one is we're going to be solving it for all degree solutions. So we're going to do this one in class together, but I want you guys to kind of take a peek at it beforehand. So to start off, we're going to solve this. 2 cosine x minus 1 equals 1 over cosine. Notice right away we are in radians. My bounds are in radians, so I need to solve it in radians. So the thing that makes this tricky is that in the right-hand side we have a 1 over cosine right here. And I cannot solve this when it's a 1 over cosine on one side. So I'm going to multiply both sides by cosine x to get rid of it. So on the left-hand side, I'm just left with 1. And on the right-hand side, I need to distribute this to both terms. So I have a 2 cosine squared x minus cosine x equals 1. So now I don't have any more cosines in denominators. Now I'm going to subtract over 1 from both sides. So I get 2 cosine squared x minus cosine x plus, minus 1, not a plus 1. Equals 0. Now that's something I can factor. I know on 1 I'm going to equal 0. I'm going to have a 2 cosine x and a cosine x. Now whatever goes in the second spots for both has to multiply to 1, so I only have one choice, 1 and 1. One of them has to be positive, one has to be negative. Turns out that it's a plus 1 and then minus 1. Okay, so I set them both up separately, equaling 0. I'm not going to write out the individual steps. On the first one, we have cosine x equals negative 1/2. And then we have cosine x equals 1. So let's think about this left-hand side. Cosine x equals negative 1/2. What are my quadrants where my cosine is negative? Well, that's 2 and 3. So I have 2 triangles there. 1 in quadrant 2, 1 in quadrant 3. Now my adjacent is negative 1. My hypotenuse is 2, so that means the opposite sides are square root 3, negative square root 3. So I have a 60 degree or a pi over 3 reference angle. Let's think about it. I'm a pi over 3 short of 1 pi. So one of my answers becomes x is equal to 2 pi over 3. And then on my second triangle, quadrant 3, I'm 60 degrees past 180, so it's, or pi over 3 past 1 pi. So I get a 4 pi over 3. Again, if you wanted to solve those using degrees and then switch them over to radians, perfectly fine. Now let's talk about the second one here. My second one is cosine x equals 1. If I'm on my unit circle, or my quadrant plane, my cosine is the x value. So I need to think about, hey, where is the x value 1? Well, that's the only place is right here. Now, since I'm including 0 and 2 pi on my interval, I have to include both of them. The first one is at 0. I don't move. I'm at home base. So one of them is x equals 0. Now I could go all the way around and back to my starting point, which is 2 pi. And since my interval here is including 2 pi, I have to include that in my answer. So my answer has 4 answers to be exact. 2 pi over 3, 4 pi over 3, 0, and 2 pi. Got to include all 4 of them. Ooh, this one looks like fun. Sine of 2 theta plus root 2 cosine theta equals 0. Now notice right away I'm in degrees, so my answer is in degrees. Now I cannot answer this right now because this has a 2 theta. I cannot solve an equation that has a 2 theta in it. I have to switch it over to regular theta. Well, using my double angle identity, I know sine of 2 theta is 2 sine theta cosine theta. And I'm going to leave the second term the same. Root 2 cosine theta equals 0. Ooh. So right off the bat, it didn't look like that helped me. But what I can do from here is I can factor out a cosine theta from both terms. It has a common term, so I'm going to factor that out. Cosine theta, I'm left with a 2 sine theta, and I'm left with a root 2. Now notice this kind of looks the same as when I had factored it. I have two terms, cosine theta, and then my second term is this 2 sine theta plus root 2 theta. Since they're equaling 0, I can pull them apart and set them both equal to 0. So the first one I get cosine theta equals 0. And on the second one, we'll do that in red. I have once we solve it, I get sine theta equals negative root 2 over 2. Now this is similar to negative 1 over root 2. And I write it like that so that when I draw my triangles, I'm going to realize, hey, that corresponds to a 45, 45, 90 triangle. But let's start with the cosine theta equals 0. Think of my coordinate plane here. Remember, cosine theta is the x value of the point. So where's my x value 0? Well, straight up and then straight down. So I have two answers there. I get theta is equal to, straight up is 90 degrees, and then straight down is 270 degrees. So on that one side, I get two answers. Let's think about the second part here. Sine theta equals negative 1 over root 2. Draw my triangles again. Now I have to realize, hey, sine is negative here. And sine, using all students take calculus, is negative in quadrant 3 and in quadrant 4. Sine is opposite over adjacent. Opposite over hypotenuse, sorry. So I get a negative 1 and then a root 2. Negative 1, root 2. So this means this is a negative 1 and a positive 1 because it is a special triangle. So my reference angle here is a 45 degree reference angle because of my special triangles. So that first one in quadrant 3 is 45 degrees past 180, so I get x is equal to 225. And my second triangle is 45 degrees short of 360, or 315 degrees. So again, I get two answers per side, so I get four answers total. 90, 270, 225, and 315. This one looks like fun. Cosine 2 theta plus 3 sine theta minus 2 equals 0. Notice again I have this 2 theta. I cannot do anything with this until I switch it over to a normal theta. Now remember back to all of my identities, I have 3 to choose from for cosine. But in the second term here, I have a sine theta. So I'm going to use the cosine 2 theta identity that only deals with sines. I want to get only sines left when I solve. So this becomes, using that identity, 1 minus 2 sine squared theta then everything else stays the same. Plus 3 sine theta minus 2 equals 0. Let's do a little solving, rearranging, combining. I get minus 2 sine squared theta plus 3 sine theta. Okay, plus 1 minus 2, so that's a minus 1 equals 0. Now because I have this negative 2 out front, I'm going to factor out a negative 1. Get rid of the negative sign. So I have a negative 1 times. This becomes a positive 2 sine theta, sine squared theta, minus 3 sine theta, plus 1. Now I could split this apart and set them both equal to 0, divide by negative 1, however you want to think about it. The negative 1 just goes away. We really don't care about him anymore. And now I can factor whatever's left. I know that I'm going to have a 2 sine theta for one of them, and a sine theta for the second one. Now I have to have my last terms multiply to a positive 1 and add to a negative 3 when I incorporate my 2. So they either both have to be negative or both positive. Well, they're both negative 1s. So now I set them equal to 0 separately. The first one I get sine theta equals a half. And then sine theta equals 1. So on this first one, think about where sine is positive again. Quadrants 1 and 2. Sine is opposite over hypotenuse, so 1, 2, 1, 2, negative root 3, root 3. Well, it turns out that my reference angle is a 30-degree reference angle. So for that first one, it's just a 30-degree answer. For the second one, I'm 30 degrees short of 180, which is a 150-degree angle. So those are my two answers for the first part. Second part, sine theta equals 1. If I think about my coordinate plane here, sine is the y value. Where is the y value 1? Well, it's just straight up. So I get theta equals 90 degrees. So on this one, I only get three answers: 30, 150, and 90. And then the last one, which just looks like so much fun: 4 cosine squared x plus 4 sine x minus 5 equals 0. Now you may think right off the bat, hey, can I just factor it? No, I cannot, because I have a cosine squared in the first part and a sine in the second part. But I'm going to use the Pythagorean identity here to say, hey, this is 4 times 1 minus sine squared theta. Oh, x, sorry, we're in x's. Plus 4 sine x minus 5 equals 0. And now let's distribute. I get 4 minus 4 sine squared theta, x, sorry, my mind's in theta for some reason, plus 4 sine x minus 5 equals 0. Combine like terms, I get a minus 4 sine squared x. Man, I just want to write theta for some reason. Alright. I have a plus 4 sine x, and I have a plus 4 minus 5, so I get a minus 1 equals 0. Now again, I have this pesky negative sign out front, so I'm going to factor out a negative 1. So I get 4 sine squared x minus 4 sine x plus 1. And now this negative sign doesn't matter. And now I can factor whatever's left. Well, I get 4 sine squared x, so I end up getting a 2 sine x for the first part and a 2 sine x for the second part. And now whatever's in the second position for both parentheticals has to multiply to plus 1, so they either have to be both positive or both negative. They are in fact both negative. Notice they're the same. I have a 2 sine x minus 1 and a 2 sine x minus 1. So when I separate them both together, and set them both equal to 0, I'm going to end up getting the same answer. Now I don't have to write it twice, because the same answer twice is just the same answer. So I'll go through and write them just write one of them, because you end up getting the same answer for both, and you don't need to incorporate those, because if I answer it once with an answer, I don't have to answer it again with the same answer. So I only end up getting a sine x equals positive 1/2. Now again, just to clarify, since it's the same for both of them are the same here, I don't have to write it twice. I just have to write it once. So sine x equals a positive 1/2. So I'm in quadrants 1 and 4 again. Let's see, we get 1, 2, 1, 2, negative root 3, root 3. And again, I get a reference angle of 30 degrees. However, I'm answering in radians here. My bounds are in radians, so I have to answer in radians. So that's a pi over 6 reference angle. So let's think about what I get here. For the first quadrant, 30 degrees is a pi over 6 answer. And then for the second quadrant, I'm a pi over 6 short of 1 pi, or 5 pi over 6. And there are my answers. So go ahead and write your summary and any questions you have, and then please take a look at this assignment for tomorrow.